In this video, we're going to look at variation. Now this first example, we have the stopping distance of the car directly proportional to the square of the car's velocity. With any of these questions, you should always define variables and don't just use x and y all the time. So here, we can let d be the stopping distance. And we'll put that in meters. And then v is velocity. And this will be kilometers per hour. Now the variation statement, all this is d is proportional to v squared. Just putting the words into algebra, and we use the symbol alpha for proportional to, or varies with. Now, that's the same as d equals k v squared, where k is the constant of proportionality. We can solve for k using the 32 meters and the 60 meters per hour, or kilometers per hour. We don't have to worry about units. K will take care of that. And we end up with k equal to 2 over 225. Now yes, you could divide this out and get a decimal, but it's just easier to leave it as a fraction and it'll be more accurate. But we want to know the equation. So the equation relating the variables will be just this. From there, we can now use that equation for part D, which will be, well, it's a D, not a B. So plug it in. 2 times the 90 kilometers an hour divided by the 225. And we get an answer of 72 meters. Now this one here is just a generic one, doesn't have any particular application, but we have z varies inversely with the cube root of w. So z varies inversely with the cube root of w. So whenever you see the word inversely, it's 1 over. Now we can use the 20 and the 8 to find the value of k. So z is 20 when w is 8. We can multiply that up. Cube root of 8 is 2. 2 times 20 is 40, which gives us our k value. So we now have z equals 40 over cube root w. And we can find z when w is 15, which is approximately 16.2. Now here we have a bit of a physics question. The resistance of a wire varies directly with the length and inversely with the square of the diameter. So, should define variables here. R for resistance, which will be in ohms. L for length, which in this case will be meters. And D for diameter in millimeters. From there, R is proportional to L over D squared, or R equals KL over D squared. Now we can plug in the first set of numbers to figure out K. So we have 45 equals K 8 over 12 squared. You'll end up with K equal to 810. So R equals 810 L over D squared is our formula. And then we can use that to figure out for the last example where we need to figure out the diameter. So 60 equals 810 times 15 over D squared. We can multiply the D squared up. 810 times 15 is 12,150. Divide both sides by 60. We get 202.5. And then take the square root. Now technically it is the plus or minus square root. But D is a diameter. So D can only be the positive. So D is approximately 14.2 millimeters. Now this last example, we don't have any values to plug in. We have m being increased and tripled and p halved, and we're going to try and figure out what happens to t. So we have t proportional to the cube of m, the square of n, and the square root of p. So t equals km cubed n squared over root p. Now it says m is increased by 60%. So 60% plus 100% is 160%, which is 1.6 m. N is tripled, so that's just easy. It's becoming 3n, and p is halved, 0.5p. So we're just going to plug all those into this here. So t is now k 1.6m cubed 3n squared over root 0.5p. We can factor things around. So we get 1.6 cubed 3 squared over root 0.5 times km cubed n squared over root p. And that's just using properties in algebra that we already know. We can calculate out that factor out front, which gives us 52.134 km cubed n squared root p. So therefore, t would be multiplied by a factor of 52.1. Or you could think of it as increased by 5,110%. 5,210 minus the original 100%.